The data elements are added at the top position. Even removal of an element takes place at the same point called top point. Decrement the top pointer. It was 1, 1 minus 1 is 0. Top point is at the 0 index or at this position. Now this is the element to be removed. If there are no element, still we are trying to remove the element from the stack. It results in error or exception that is called underflow. Dear students, welcome to Computer Science classes. I am Ravi Kumar KR, lecturer in Computer Science, Vidhyaashram PU College, Temple of Excellence, Mysuru. Students, let us start our discussion with the chapter 3, stack. In this session, we are going to discuss about the stack, definition and introduction, and operations on stack. These are the topics to be covered in this session. Okay. Let us start with the definition or introduction to the stack. So, in introduction, a data structure defines a mechanism to store, organize and access data along with the operations, processing that can be efficiently performed on the data. So, here let us see the definition of data structure. So, what is a data structure? A data structure is nothing but it is a mechanism where we can store the data and we can organize the data so that we can access easily. See, that is the concept of data structure. See, we know what is a data and we know we are storing different types of data in computers. See, whatever the data we are going to store in a computer or in the data structure, it should be easily accessible by the user. So, that is with that concept. So, what is a data structure? Data structure is a mechanism so that it is going to store the data and organize the data so that it is easy for users to access the data along with operations or processing. I mean, we are going to learn in our further slides about different operations on data structure. So here, and efficiently performed on the data. This is the main definition of data structure. Now, a data structure organizes multiple elements in a way so that certain operations on each element as well as the collective data until could be performed easily. So, this is another feature of data structure. So, data structure is going to organize the data and with multiple elements. So, if we talk about the data, we can have different types of data and multiple elements or more than one elements. So, that is a data structure. So, data structure is going to organize the different types of data or multiple data elements in a way so that operations it can be performed on each element or a collectively to a one data structure. That is the feature of data structure. Now, stack and queue are popular data structure used in programming concepts. So, here stack and queue. So, these are the data structure or example for data structure with respect to programming concept. So, here we have learned the definition of data structure. You know what is a data and we have different types of data and how to store it, where we are going to store it. One method is by using data structure with respect to programming concept. So, with respect to programming concept, it is a data structure. We are using it to store the data and we are organize the data so that it is easily accessible by the user. That is the definition of data structure and stack and queue are examples. In the next slide, we will see what is a stack. What is a stack? Here, an arrangement of elements in a linear order is called a stack. So, what is a stack? First is a data structure and here the elements are arranged in a linear order or fashion. Now, if we look at this diagram here, these are all example for stack data structure. So, if you look at this here plates, so here how we are going to arrange the plates maybe at home or maybe at some restaurants. Here we are keeping one over the other. It is called stack of plates. And if you look at the books and how the books are arranged here. So if you keep one book over the other, a number of books, it forms a stack of book. And this is another example is how we are going to keep the CDs. So here, if you talk about CD box, we are going to keep the CD one over the other, maybe 10 CDs or 12 CDs. So whatever the number, so it is a stack of CDs. So this is how we are simulating or we are illustrating the stack data structure. So it is an example for stack. Here, that is the meaning of here, elements are arranged in a order or in a linear order. We add new elements or removing existing element from the same end, commonly referred as top of the stack. So this is the word top of the stack. If you look at the example here, so here if you look at take the example of here a stack of plates. So here these plates are kept one over the other. So here we start from this point and this is where the last point. Suppose if I want to take out one plate from here, normally what we do is we are going to take out the plate from the topmost one. So it is difficult for us to take out from the middle of the stack. So we are going to take out the topmost plate to the outside or out of the stack of plate here. So that is the meaning here, top. So this is called a top. This is we refer as top is a pointer or is a point where we are removing the plate from the stack. Similarly, in the same way, suppose if I want to add a few more plates over it or I want to add few more plates to the stack of plate here, then where is the place for us? Generally, we are going to start from this point. So that is the meaning of the sentence here. Adding a new element and the removing a new element takes place at only one end. It is called top. See, this is one of the feature of stack a data structure. The meaning is adding a new element and removing the new element at the same pointer called top pointer or one place. That is the one of the important feature of stack data structure. Now, it follows the last in first out principle. And here, what is last in first out, or we say LIFO principle. Stack follows LIFO principle. LIFO stands for last in first out. So what is the meaning of that? So here, as I told you just now, say this is the plate we have added at the last. So if you consider this an example here, the last place we have added recently, the last plate. So if I want to remove it, only have to take out the last element or the last plate. So that the meaning is last in first out. So this is a plate which we have recently added as the last plate, and that is the same plate has to be removed from the stack. That is the meaning of LIFO or last in first out concept. So here stack follows LIFO principle. Now the element which was inserted last, the most recent element, will be the first one to be taken out of the stack. That is the concept of LIFO. So according with respect to programming concept, so element, so it is not possible for us to take out any plate in between or in between the stack, or we cannot take out from different location. That is with respect to programming concept, only we have to add the element in a linear fashion or in the linear order or in definite order, and removing has to be done in the same LIFO principle. That is the definition of stack a data structure. In the next slide, let us see what are different applications of stack in programming concept. One is to reverse a string. To reverse a string is a program to reverse a string is an example for stack. For example, here if I write a word like computer, COMPUTER. So in this example, so I want to write a program to reverse the string. So this is the string here. I want to reverse it. If I want to reverse it, I am going to write this one first. That is R. This is the second one. Then TUPMOC. So here while reversing, we are writing the last element first. So last in, first out. If you assume that, if you think that LIFO, this is the last character we have written here, and if I want to write a program to reverse the string, so this one we have to write first. So this is the first element here, then the second one, it goes like this. So reversing a string, a program, is an example for application of a stack. Second application is in text image editor. We are using the text image where we have options to redo and undo the editing option. We are familiar with editors. For example, MS Word is an editor. So we know how to work with MS Word. So in MS Word, suppose there is an option like undo and redo button or undo and redo option. So what is undo button will do, or action, this action is going to cancel the previous action. That is the function of undo. And what is redo? Again, is going to repeat the same action which was deleted or which has been undo it. So this is the concept of redo and undo in a program or in a text editor. We have been using this. So this is an example for our applications of stack. Next, one more example is while browsing the web, we move from one page to another page by accessing links between them. In order to go back to the last visited web page, we may use the back button to move to the previous browser or previous web page. So this is also an example or applications of stack. Evaluating arithmetic expressions in a program. So this is we are going to discuss in the further slides. So these are all the different applications of stack, a data structure. In the next slide, we will see what are different operations can be performed on stack. So this is operations on stack, or we can understand that the different processing or what are the data structure, how are the elements we can process by different functions. All these referred as operations on stack. So here the first operation is called push operation. The first operation is called push operation. One of the operation. What is the definition of this? So here the push adds a new element at the top of the stack. It is an insertion operation. So here one of the operations is called push operation. Another name is called insertion operation, and it is going to add a new element at the top position. See, we have seen the definition of stack. So as per the definition, it is a LIFO principle, and the data elements are added at the top position. Even removal of an element takes place at the same point called top point. So it is the push is an operation to add new element to the stack at the position top or at the pointer top. We can add elements to a stack until it is full, obviously. Now you know what is a stack. See, there is a limit for it, isn't it? So suppose if you assume that this is a stack of elements, this is a stack, we are assuming that there are 1, 2, 3, 4, there are 4 positions, or we can say there are 4 places, and here we can keep on adding elements to the data structure until it is full. So once if it is full, we cannot add any new element or any data into the stack. Similarly, so here we can add elements to a stack until it is full. This is the limit or defined in the programming concept. A stack is full when no more elements can be added. Now how can you say the stack is full? So once if we are not able to add any new element to it, so once if it is crossing the capacity, then we say that the stack is full. Now trying to add an element to a full stack results in exception called overflow. This is exception handling, you might have learned in the previous chapter. So if at all, here already we have defined in this example, for example, I say size is 4. If I say size is 4, only we can add 4 elements. Suppose if I want to add one more new element like E or character E to the stack, it results in an error that is called exception, overflow exception or error. See, this is the concept of the push operation. So what is push operation? Another name is insertion. So any element, new data we would like to add into the stack, we have that operation is called push operation. It is going to add new element at the top position or at the top pointer and until the stack is full. So this is push operation. Now let us see with the diagram how is going to work. Now assume that this is a stack we have declared here or we have defined the stack here, and at the beginning this is empty. This is empty, there are no more elements. Assume that the top equal to 0, 1, or we can say it is minus 0 is a minus 1. Minus 1 means 0, because if we are going to implement stack in a list data type, in the list element, its index start with 0. So if I say minus 0, 1 or minus 0 means it is empty. So this is with respect to list data type or a data structure, we are implementing stack or push operation. Accordingly, if the top pointer equal to minus 1, it is empty. This is one of the condition. Next, suppose if I want to add one element to it, look at this diagram here. I am going to add one element to it. Then what is happening here? The pointer top, it was minus 1. Now it becomes 0. Means we are going to increment the top. For example, here top, it was minus 0 at the beginning. Now if I want to add 1, we have to add 1 to it. So minus 1 and plus 1, it is 0. So now value is 0 means this is the position of top pointer. Top pointer is 0. So this is the place we can add one element to it. See, this is called push operation. So always insertion takes place at the top position. Now if you look into that example, here top pointer was a minus 1. Now it is minus 1 plus 1, it is 0. Top of 0 is the first element with respect to list data type or data structure. Now we are pushing one element. Now if I want to push one more element B, now again we have to push this top pointer to next position. Again here 0, again 0 plus 1 equals to 1. So at this position, top pointer at 0 index, it is at 1 index. So this is first index. So we are going to add element B or character B into the stack. See, this is push operation. Similarly, if you want to push one more element or element C or a character C, again we are incrementing the pointer here. So here top equals to 2, top equal to 3. So this is the final stack. So here assume that this is start with 0, 1, 2, 3. So at the beginning, if you look into that, top equals to minus 1 means it was empty. Now this is 3. Now end of this, we observe this, the top pointer is at the position 3 or the index 3. This is end of a stack. So we cannot add new more element to it. So this is how we are going to add new element into the stack, or this is push operation in stack. Now let us see another operation on stack, that is pop operation. So pop operation is used to remove the topmost element of the stack, that is the element at the top of the stack. So what is pop operation? It is used to remove the element, and as per the stack principle, only we have to remove the top element or the element which has been added recently. So that is the definition of this pop. And because we know that insertion and deletion takes place at the same pointer called top with respect to stack data structure, it is a delete operation. So removal of element is nothing but deletion operation. We can delete elements from the stack until it is empty. So as long as there are no elements in a stack, we can do this operation, or we can remove the elements. Once if there are no elements, or we say once the stack is empty, means if there are no elements, this pop operations cannot be performed because there are no elements. Trying to delete an element from the empty stack results in exception error called underflow. Again, if there are no element, still we are trying to remove the element from the stack, it results in error or exception that is called underflow. And if you look in the previous slide, we have learned about push operation. In push operation, if we are trying to insert element at the beyond this capacity, then we are getting the error message or exception like it is overflow, and here it is underflow. So this is the definition of pop operation. Now let us understand the concept with this diagram here. Now this is once the stack is full here, this is the condition. Now 1, 2, 3, 4, this is the capacity of the stack, there are 4 elements. Now look at this condition, stack is full. What is the meaning of stack is full here? The meaning is that there are no elements to be added. Now we want to remove it, only have to remove the first element. In this example, the element 4. So in this one, if you look what is top equal to 3, so as we know that the index start with 0, 0, 1, 2, 3. See, now at this stage, the top is at the index 3, the element is 4. If I want to remove this, or if I want to perform pop operations, we have to remove only the first element, that is 4. So once the top equal to 3 means this element will be deleted or removed from the stock. Once the element has been removed, then observe that here the top is 1, 2, 3, 4. Now if you observe this, here we can say only 1, 2, 3 because the value of the top is 2. Here value was 3 after removing the element 4. The element at the top point, the top position, now we have to decrement the top pointer. We have to decrement the pointer. So 3 minus 1 is 2. Now the top pointer is at the index to 0, 1, 2. So next element to be removed is the element 3. So in this example, now element 3. Now if I say top equals to 1. If I say top equal to 1, index 0 and index 1. So if I say top equal to 1, so in this example, the element 3 which has been removed from the stack with the help of pop operation. Now again, when the top equal to 0, when top equal to 0 means this is the index. Now after removing the element 2 at the top equal to 1, next decrement the top pointer. It was 1, 1 minus 1 is 0, top point is at the 0 index or at this position. Now this is the element to be removed. So in the next step, if I say top equal to, it should be minus 1. When the top equals to minus, here 0 minus 1, we have decremented. So here top equals minus 1. Once if I say minus 1, the condition is called empty. We have seen in the beginning of the slide. So when the stack is empty, when there are no more elements, so it is the empty. And how do we indicate it? With respect to programming concept, we have to say top pointer equals to minus 1. So when it reaches to minus 1, understood that here stack is empty, no more elements to be removed, or we cannot perform pop operation. So this is the pop operation with respect to stack data structure. In the next slide, we will see the implement of stack in Python programming. So whatever we have learned so far, with respect to theoretically we have learned the stack, definition and operations, push and pop operation. Now let us see how do we implement it in Python programming. So here, simple method to implement is by using data type list. So here we are going to work out the stack operation with respect to data type list. You have learned what is a list in your last year or previous year. Now, first one is I want to create an empty stack. Before you start writing a program, the first step is with respect to stack is we have to create an empty stack. So there we can do any operations as insertion or deletion or push and pop operation. So first step is to create a stack. So with the respect to programming, we can say class stack equal to list. So this is data type. We are going to create a stack. The here class stack is the name. This is the name of the stack. name of the stack here, and here this is identifier. We have learned what is identifier. Whenever with respect to programming concept, while writing the name of variables or identifier, we have to follow the rules we have learned last year. That is no special characters, no space, you can have alphanumeric character. Those things we have to follow with respect to identifier. So this glass stock is an identifier. So this one name. Here in this example, we have created a data structure that is name. Name of the data structure is stack. Glass stack is name of a stack. Next one is, this is one syntax. In the next second syntax, I want to check whether the stack is empty or not. Now, this is, we have created the list or a data structure. Next, I want to check whether it is empty or not. So, what is the programming statement? It goes like this. def, this is the name of the function, is empty. Is empty is name of the function here. Is empty. And here we are passing the parameter, name of the stack, glass stack. What we have defined here, same thing we are using here. So this is glass stack is the stack we have created. I am using the same glass stack as the name of the stack as a parameter. So here colon as a syntax, if length of glass stack equal to 0, length is 0. Here length is the function, it is an inbuilt function. If length of glass stack equal to 0, then it understand that return true. Return true means it is empty, else return false. So here with the help of length function, we are checking that whether the stack is empty or not. So what is the meaning of a length function? Length function here, it indicates or it returns the number of elements in a stack. If there are 4 elements, it says the length equal to 4. If there are 0 means the length is, the stack is empty. If the length of the stack is 0 means there are no more elements, we are checking this condition here. So if length equal to 0, it is true that return true means it is empty. Else means false. So this is the programming statement, or we are defining a function is empty to check whether the stack is empty or not. In the next slide, it is a code or a programming statement to push operation or to insert new element into a stack. So here, as per the syntax definition, we are defining a function. The function is op push is name of a function, and here glass stack and element. This glass stack is name of the stack what we have declared here or what we have created here. We have to use the same identifier at this point. So glass stack comma element is the new element to be inserted into a stack. So definition here we are using glass stack dot append element. See here, observe this. We are using one more append function. We are using append function or append method to insert element into a stack. And how we are using this, what is the syntax of that? Here glass stack is name of the glass stack what you have declared or what you have defined here. This one dot is an operator, dot append is a function, element is the element to be inserted. This is the syntax of push operation. Here push operation we are doing it with the help of append method or a function. Next one is a function named size to read the number of elements in a stack. Say we have one more function called size function. We are defining here is going to give us how many elements are there in a stack, or we can say either length of the stack. So here we will use the length function of a list in Python to find number of elements in the stack. Now here the function is def, size is the function of glass stack. So as I said, this is the name of the stack what we have created or defined in the program. Next one, return length of glass stack. So this is the length function, we are using it to display or to know the size of the stack or number of elements in a stack. This is the one function called, we have defined size function. Now let us see, next function is a function to read an element. I want to display, I want to read the element of a stack. We have seen what is the function of that. So here the function name top. to read the most recent element in the glass stock. It is a name of the stack. So here we are using a top function, means we are defining a top function to know or to display the last element of a stack, or we can say the recently inserted element of a stack. So the function is definition top of glass stack if is empty. We have already learned the syntax of this. It is empty of glass stack, print stack is empty and return none. It is obviously it is true. Now we can display the last element or the first element of a stack if there are elements in a stack. Suppose if there are no elements, if the stack is empty, it is not going to return any element from the stack. So it is return none. Else means stack is not empty. So we are using x equal to length of glass stack, element equals glass stack of x minus 1. Here x is nothing but a variable, minus 1 is the 1, because if I say size is 5 means last index is 4. That is how the list functions in Python programming. In a list, the index starts with 0. Suppose the size of list is 5, means there are 5 elements, but the last index is 4. So here we are going to display the last index x minus 1. It is going to return the same element or the element at the top pointer. This is a function to read or display the topmost element in a stack. In the next slide, we will see pop operation, or how do we write function by using pop operation. Here def is a function, op pop is a function. This is the name of the stack. If it is empty, obviously we have learned the definition in our previous slides. If it is no elements means underflow, we cannot remove any element from the stack. So otherwise else means if it is not empty, then we can say return glass stack of pop, means we are removing the last element from the stack, or we can say it is possible to remove the element at the top position by using pop operation. This is the function here. Now let us see, next one is to display the element. We are using to display the element, we are using one more function, display. This is name of the stack. We are finding the length of the stack and current element in the stacks are, we are here, observe this, we are using looping structure, we are using for loop to print the elements of a stack. So this is nothing but elements in a list. So here we are using for loop, I in range, x minus 1 to minus 1 and minus 1. So here observe this, suppose x is the length of a list, last index is, it is x minus 1. So this is a starting point, this is the last value and this is the step value, means we have to decrement it. Suppose if I want to list all the elements, if the last element is at the index 4, next one is index, we have to decrement the index or top pointer. It is after 4 minus 1 is 3, 3 minus 1 is 2. So it should go like this is the step value. Then print glass stock of I. At the beginning, x minus 1 is going to print the topmost element of the stack. Then with the help of for loop is going to print the next previous element of the stack. So this is a display function to display or to the elements of a stack in programming. Dear students, so far in this session, we have learned the definition of data structure, stack, and also operations on stack like push operations and pop operation. And also we have learned the coding or nothing but Python programming statement to insert, remove elements or push operations or pop operations. Let us continue our discussion in my next session. Thank you very much.